We are going to continue on in Unit 2 and utilize some more Lewis symbols. This time we're going to apply Lewis symbols to ionic compounds. And one of the most common ionic compounds that you come across and that you're probably familiar with before taking chemistry is sodium chloride, NaCl. So this is table salt, and if you're ever looking to impress anybody, you can use table salt to do so. Maybe a lot of you know this trick already, but if you have a napkin that's sticking to your drink, say you're at a bar and this napkin's sticking to your drink and it's really embarrassing and you're not sure whether the napkin should go with your drink or on the table, one of the things you can do is sprinkle table salt on your napkin, and that way when your drink sits on the napkin, it's sitting on top of the sodium chloride cubes. So your drink will no longer be able to stick to the napkin because it will have those cubes to rest on the sodium chloride. So just a little silly thing, but maybe it'll make you think a little bit more about chemistry. So sodium chloride, like I said, is an ionic compound. Sodium has one valence electron, so that's what its Lewis dot structure, Lewis symbol looks like. You can have that dot anywhere you want, either the top, bottom, left, or right, just as long as there's one dot. Chlorine has 7 valence electrons, and it looks like this. Again, you could have your unpaired electron in a different location than mine, which is fine. So what happens is that sodium loses an electron, chlorine gains 1 electron. So now you have sodium with a +1 charge, and you have chlorine with 8 valence electrons and a -1 charge. So this is how you indicate ionic compounds with Lewis symbols. You can do the same thing when potassium reacts with bromine. And I should change this to Br to form potassium bromide. So it's going to look exactly the same as it did for sodium chloride. So you have 1 electron here, 7 electrons here. This is going to lose 1 electron. This is going to gain 1 electron. So now you have potassium +1, and then you have bromide ion, the -1. Now, so the formula for potassium bromide will look like this, because it's just 1 to 1. Now moving on, magnesium reacts with oxygen to form magnesium oxide. Magnesium has 2 valence electrons, and it looks like this, or any way you want your dots, just as long as they're unpaired. Oxygen has 2 paired and 2 unpaired, so you have 6 electrons here. What ends up happening with magnesium oxide is that you lose 2 electrons and you gain 2 electrons. So you're going to have a +2 charge on magnesium ion, and you're going to have a -2 on oxygen. So the formula for this will be Mg. Now a quick way to figure out what the formula needs to be is to just cross and drop. So you get Mg2O2. But with ionic compounds, this is the simplest ratio. So it must be MgO, because you can divide both of these by 2. So with all of these compounds, your charges add up to 0. +1 -1 equals 0. +1 -1 equals 0. +2 -2 equals 0. Let's look at potassium oxide. Potassium has 1 valence electron, so you have 2 potassiums reacting with oxygen, so we have 1 electron each times 2, and you have 6 electrons here. Now again, the reason this happens is because you want an octet. So each one of these loses an electron, So you end up with K+, and then oxygen gains 2 electrons. So you're going to have 2 minus. So the formula that you would get for potassium oxide, cross and drop, is K2O. And that makes sense. Let's go through the math because we have 2 ions at a +1 charge minus 2. So we have 2 minus 2, that gives you 0. So this is how we use Lewis symbols to represent ionic compounds. In the next lecture, we're going to talk about how to name ionic compounds and how to write their formulas.